Bismillahirrahmanirrahim. Assalamu alaikum and welcome to another lecture on tool and die design. Today we are going to start module number 1, that is design of fixtures and jigs. Fixtures and jigs are workpiece holding devices that are used in machining processes. We have divided this module into different parts. In first part, we will discuss why do we need fixtures and jigs? What is the importance of fixtures and jigs in a machine shop? So by the end of this lecture, you should be able to understand the importance of using fixtures and jigs in machining. You should be able to differentiate between a fixture and a jig, and you should be able to understand some general considerations for designing fixtures and jigs. We will watch this very good video on workpiece holding basics by Society of Manufacturing Engineers later. Fixtures are used in machine shop. They are used in machine shop and they are strong, rigid mechanical devices which enable easy, quick and consistently accurate locating, supporting and clamping blanks against cutting tools. So the words written in green actually show the main components or parts of a fixture. So the fixtures comprise a locating component, a supporting component, and a clamping mechanism or a component. Sometimes in some fixtures and jigs, locating the workpiece and supporting the workpiece, both objectives are achieved through the same components, and sometimes we need two separate components or two separate parts of a fixtures, separate parts of a fixture, one to locate the workpiece and other to support the workpiece. And then we need some mechanism or device to clamp the workpiece. So fixtures result faster and accurate machining with consistent quality, functional ability, and interchangeability. So that is very important benefit of fixtures and jigs, that we are able to repeatedly load the workpiece in the fixture and jig in the required orientation so that the parts made are within the same range of variation. They have the tolerance, they have the limits within the allowed range, so we can use them interchangeably. Jig is a fixture with an additional feature of tool guidance. And remember that whenever we are talking about a jig, we are talking about some workpiece holding device that is to be used on a drilling machine. And tool guidance here means guiding the drill bit for the most part, or sometimes reamer or tab if we are using it on the required position on a part, right? So that is meant by tool guidance. So we are able to guide the drill bit at the exactly required point where we have to make a hole. So we can say that if we are having these features: locating, supporting and clamping, these three features. And as I mentioned, sometimes locating and supporting is done using the same component. So that is a fixture. And if the feature of tool guidance is added to this fixture, conceptually of course, we have an additional feature of tool guidance, then that becomes a drilling jig or simply a jig. So we can say that a jig is a fixture with additional feature of tool guidance. Or in other words, we can say that every jig is a fixture as well. I hope you have got the idea. So what is the ultimate goal? What we want to achieve? We ultimately want to achieve productivity, increase in productivity, and increase in quality, or to be able to achieve consistent quality. So after a workpiece is machined and removed from the fixture or jig, the operator should be able to quickly put another workpiece into that fixture or jig. So we want to make the process faster as well, so that productivity is improved. And after that, machine it to the print dimension with the tolerance permitted. So of course the part should be meeting the print requirements as well. So let's take a very simple example very quickly. We have a circular disc of a certain diameter D, a certain thickness B, and from the center of this disc, we need to drill uh, a hole of diameter small d, and this hole, the center of this hole to be drilled should be at a distance of x from the center of this disc. Suppose we don't have any any jig available, and using conventional tools in a workshop and of course drilling machine, which steps will be required to drill this hole? I would recommend you to pause this video and list down the steps that will be required to drill this eccentric hole that is not at the center of the disc but at a distance x from the center of the disc. So which steps will be required using conventional tools available in a machine shop? We don't have any jig available. I hope you have listed down the steps required to make this hole. Let's very quickly go through the steps that might be required. So they include cleaning and deburring the blank or disc, marking on the blank, showing the location of the hole and its axis on the blank, punching the center at the desired location, mounting the blank in a drilling vise, a small V block, etc. to provide support and clamp the blank firmly. Position the vise along with the marked blank to bring the hole axis in alignment with the drill axis. And this can be done in a couple of ways, either adjusting the vise position with respect to fixed drill axis, or moving the drilling machine table and then locking the table position, or moving the radial arm and drilling head in the case of a radial drilling machine. And we may have to check the alignment again and again, and finally we will be drilling the hole after we are sure that the point at which hole is to be drilled is exactly under the center of drill bit. So you notice that so many operations are needed. So it is a tedious job. It requires a lot of care and skill to drill this hole. And it was a simple operation. We had to drill just one hole at a specified position. And even after that, there may be inaccuracies in machining. Especially we can expect part-to-part variations in this case, because everything is being done manually. So we can expect a lot of variations part to part. So what is the solution? One solution is to go for automatic or special purpose machine tools. So if we are going for mass production, if the quantity to be produced is really huge, then we could go for automatic or special purpose machine tools, just like CNC machines. This is one of the options. But they are very expensive machines, especially if we are going for batch production. Then simple but effective fixtures and jigs are appropriate and economically justified. They do not require too much cost, but they can make the production accurate as well as fast. So that is the purpose of this module. We will be focusing on when we need fixtures and jigs and how we can design them. So all the steps that we saw in the previous example, many of them can be very quickly performed if we are using fixtures and jigs. So for example, marking, punching, positioning, alignment, they are avoided. We don't need to perform these steps if we are using fixtures or jigs. Easy, quick, and consistently accurate locating, supporting, and clamping the workpiece. So positioning the workpiece in the required Orientation becomes really easy to do. A tool is automatically guided to the required position. In the case of jig, just in the example we saw, if we were using jig, we won't need adjustments of the drill bit with respect to the workpiece and vice versa. Productivity is improved. Less skill of the labor is required using fixtures and jigs. We are very much sure about the accuracy of the parts, so measurement, time, and effort is reduced. So in a way, we are increasing the technological capacity of the machine tools. So we are making work holding very quick and accurate. And as a whole, overall machining cost is reduced, and very important benefit achieved is the benefit of interchangeability. The parts made are very similar to each other and they are interchangeable. So again, to re-emphasize the basic point that we discussed in the beginning, so we need locating elements, clamping elements in the case of fixtures, and we need tool guidance in the case of a jig. So these are the minimum components of a fixture or jig. And in many cases, we do need a base or body of the fixture or jig, and we need some fastening parts as well. So part is clamped in the fixture or jig, and many times we need to clamp the fixture or jig on the machine bed as well. So you have this figure in your course pack, so we will quickly see different parts of a jig in this example. So this is a channel jig, one type of jig. So this is the part, as we discussed in the drafting practices, that it is recommended that this part is shown as red. Its boundaries are shown as red, so that will make reading the assembly drawing much easier. And this part is located through three surfaces or maybe two, depending upon the requirement. So at least this left surface and the top surface is being used as locating surface. We might be using the back surface as well. This drill bushing will guide the drill bit on the exact position where hole is to be made. So once drill passes through this drill bushing, it is automatically guided through to the required position. This is the jig body or jig plate through which this hole is drilled to insert this drill bushing, and the workpiece is clamped through this simple screw clamp. The method of locating is through flat surface. The workpiece is smooth, flat block of some metal. So the method of locating is flat surface or machined surface. There are three commonly used method of locating. So through external flat surface, through hole, or through profile. Let's look at another example. So here we are having the part, and in this case, the jig is inserted onto the part. So the workpiece is having a certain diameter, and the diameter of the jig is slightly less than the external diameter of the part. And there is a press fit or interference fit that is made between the jig and the part. So the jig is pressed onto the part. So in this case, in this very interesting example, the part is located and clamped simultaneously. We don't need any separate clamping device in this case. So the workpiece is located through its outer boundary, so that is called located through external profile. It is located through its external profile, and it is clamped through press fit. So that is very important type of a jig that is very commonly used for small quantity of parts to be drilled. Same concept is used in second figure, but the shape of the part is slightly different, and here we are having 4 holes to be drilled instead of 2. And in the third example, again the jig is holding the part through interference fit that is made here. The press fit is made here. So this is also example of a template jig. So this is the locating surface, so that is the profile of the workpiece, and through the same surface, through interference fit, the part is clamped. And we need to insert the bushing into these holes to guide the drill bit. But practically sometimes if the quantity to be made is small, so some people don't use a drill bush to guide the drill. So the drill is guided through the hole that is in the body of the jig. So again, the same summary, we need jigs and fixture to achieve accurate locating of the blank, supporting the blank, clamping the blank, and we have to make sure that part does not move at all during machining. So that is also very important, and we need tool guidance in the case of jigs as well. And as a whole, the loading and unloading the job in the jig or fixture should be easy as well as quick. Human factors should also be kept in mind.